One of the great benefits of GMT, the generic mapping tools, is that it comes with a large number of data sets and map projections that you can use in your work. So let's go over a few of these. First, let's talk a little bit about geography. GMT comes with a global, self-consistent, hierarchical, high-resolution geography database and the digital chart of the world. It includes coastlines, national and state borders, states for some countries like Canada and the US, as well as rivers and other freshwater bodies. Also, the coastline. We can use here the command GMT coast. For the region, we use the US. For coast, the -I command line option refers to water bodies that can be plotted. The little r means plot the rivers. We want them at a quarter point width and in dark blue, and you see them show up all over the place here. Next, we also want to include national borders. They're included by using the option N1 with a thick line that is black, and you can see that here US-Canada and US-Mexico borders are indicated by a thick black line. Next, we also want to include state borders. That is shown here with the -N2. They are thinner, quarter point thick and in black, and you can see them very nicely showing up here for the US and also for Canada and Mexico. All right, any other lines are going also to be a quarter point thick and black. Those are the coastlines. Anything that is dry land is going to be plotted in gray. Anything that is light blue is wet area. For the coast resolution, we use the -D command line option, and we set it to F, which is full, meaning that you have a very high resolution of coastline details, including some smaller islands. There are several lower resolutions where the shoreline becomes a lot more line segmenty. And lastly, we want to save this as a PNG and call it coastlines. We're talking about maps. We definitely have to talk about map projections. There are more than 30 map projections included in GMT that help us project the globe onto flat paper. There are 4 basic categories that we can subdivide map projections into. First, they're azimuthal or planar map projections, which we generally use near the poles, and you can see a planar projection here. Now, always imagine a map projection as having a flat sheet of paper. You're setting your globe on top, and then there's a light inside the globe. And imagine that the longitude and latitude lines are the only thing that isn't transparent on the globe. And that's how you can project the grid of your spherical globe onto flat paper. So this can be useful for polar projections. Cylindrical map projections are something that we're often doing near the equator. And then there are conic map projections where we're working in mid-latitudes. Remember that we can employ normal projections of these. So now this would be a planar normal projection would be right at the pole. A transverse planar projection would touch the equator, and oblique planar projection would touch somewhere in between. And you can see what that does to the map grid. Similarly, we can have a transverse cylindrical or an oblique cylindrical, and same for the conic projection. The normal projections are the application of these projections for use case that they were developed for, and the other ones might sometimes be of use depending on what your mapping application is. So in addition to these kind of standard categories, GMT also provides other miscellaneous projections. XY plots are also considered a projection within GMT. There are many others, and you're invited to look at the documentation to learn all about them. Additional data sets that GMT comes with includes access to external data grids via remote file mechanisms. So these data will be downloaded when you first use them, or the portion of those data sets will be downloaded when you first use them. They will be stored and read locally, and they will be accessed again for your next uses. So the download is happening only once. The data sets that GMT has access to include the Earth relief. We've seen that in the topography map already. We have a seafloor crustal age grid, which is called Earth age, Earth day and night images, Earth day and Earth night, which are the NASA blue marble images that NASA has created, and an Earth mask grid. If we're using the default preferred color palettes, we can plot them very easily using grid image. The first line shown here is the one that we used in the intro example for the topo map. You recall GMT with the grid image tool, ask it to plot the Earth relief at 10 arc-minute resolution for a global grid with default illumination and save it as a PNG into world map. And we're doing the same in the other example, only that we're switching out the grid for the Earth age, also at 10 arc-minute resolution, and save it to a file that's called world map age. This is what these look like. We've already seen the topo map of the Earth. Here is now the map of the age of the ocean floor. Now, notice that you have access to all the data values at each grid point. You're not just receiving colorful pictures that you're embedding in your maps. You're actually getting data. The example of East Pacific rise analysis in the intro part of this package showed you that you can actually analyze these data sets. So same for the crustal age for the ocean floor. You can inquire the numerical value here. You can run statistics. You can do all sorts of analyses with the actual numbers. What we're seeing here is just a visualization of these numbers. So don't mistake that as just having access to colorful plot. You have access to these data and all the tools that GMT provides to analyze data. You get a better understanding of these data sets and the tools that you can use. You absolutely have to look at the documentation. You will not get around that. The documentation for GMT really has to become your friend because of its complexity, but also the enormous power that it provides for your data analysis.